Hello everybody, in this video we're going to take a look at the transformation of certain functions. Now what I mean by that is if I have a function, and let's define f of x to start with, I don't know, well let's just use the one on the board, look, okay, as x squared. What's going to happen to this graph if I do certain things to it? So for example, let's just keep it nice and simple and straightforward to start with. What if I just add and a number on it? Now, if I have f of x and I write plus 2, okay, well, clearly that's just going to be x squared plus 2. But what will happen to the graph of that? What is it? What does x squared plus 2 look like? Well, let's type it in, okay? In fact, let's just use that original one, shall we? So we're going to say that we're going to do a plus, and ready, 2 to it. Now, what's happened? It's gone up 2 places, look, okay? Before x squared was here at 0, 0. Now it's gone up. So what has that done? That has moved up 2 places. Now, if I was being technical about this, then what I would say, it's a translation, which means movement. Okay, and if I use column vectors, well, it hasn't moved left or right at all. So I'm going to write a 0 there, but it's moved up 2 places. So one way of writing that is to say a translation of 0, 2, a movement of 2 up. Now, does that work if we did, I don't know, minus 3? So what if we did f of x minus 3? What would happen to the original function? So let's just go back to my f of x, look, okay, and there it is. Okay, we defined it originally to be just an x squared. There it is, starting at 0, 0. So now we'll put a minus 3 on it. Minus 3, what's happened to that graph? Well, it was a 0, 0. It's dropped down. Look, can you see now that point has gone down to minus 3. So what that's done is it's moved down 3 places. And again, more formally, we would say that's a translation of, now again, it hasn't moved left or right, so we keep that top number as 0. Now a movement up was a positive value, so in the previous case we had a 2 there. This has gone down, so we're going to have to write a minus 3 there. Look, a translation of 0 minus 3. So clearly, when we add a number to a function, it goes up or down. Now, again, it doesn't have to be y equals x squared, right? Okay, let's just change that. Look, let's have an x cubed here. Would the same thing work if we had an x cubed? So there's my x cubed. So if I put a minus 1 in front of this, will it go down? So take a look at that function. Look, let's move it up a little bit so you can see it, okay? So when I now type in a minus 1, does it go down? Yes, it does, look, okay? So this works regardless of the original function, whether it is a quadratic, a cubic, a reciprocal function, any defined function. If you add 1 to it, it's going to go up 1. If you move it down by 3, you will have taken 3 away algebraically. So that's how we can think about transformations in terms of movements up and down, adding or subtracting numbers. Now, there's another thing I want to look at in this video, and that is, what about if we defined f of x again? It's exactly the same as x squared. What's going to happen if we put another value in, or a number like that, for example? What would that look like geometrically? Now, algebraically, it's very easy, of course, because if f acts on x to get x squared, then f acts on x plus 2 is going to be x plus 2 squared, right? So let's go back to these functions, and we know exactly what this looks like. There's my x squared again. You can see it clearly there, look, okay? So this time, let's go back, right? And let's put some brackets into this and see what's going to happen. Remember, that minimum point is at 0, 0 right now. So if I put, let's put a minus, a plus 2. And then close the bracket. what's happened. Now, that original point was at 0, 0, remember? This looks like it's moved to the left 2 places, right? It's gone to the left. So let's write that down and see if we can spot some patterns here. So this is a translation. Let's use the correct words. Of, now, if it's moving left and right, we're going to deal with that top number, but it's not moving up or down. So I'm going to make sure that I write a 0 there on the lower number of this column vector. Now, it's moving to the left. Now, right movement is usually positive, so I'm going to write a -2 in there. So we would call this movement 2 places to the left a translation of -2, 0. Okay, now, next thing to think about, well, what happens if we start again with f of x and we think about f of x minus 5 this time, okay? So what's going to happen? Will it move left? Will it move right? Okay, and if so, how much by? So let's go back to that original function. Right, so we're going to swap that +2. Let's just put it back as it originally is. There's our original look, x squared. So if I put an x minus 5 replacing that x, let's see what happens. It's gone to the right by 5 places, right? Okay, so it's interesting that it's actually the opposite of the number you're kind of expecting here. Let's write this down. Again, it's a translation, and that just means movement. It's a translation, 5 to the right. So we're going to write that as 5, 0. Okay, this is great stuff so far. We can maybe formally define this, okay? So if I have f of x minus 2, sorry, let me start again. F of x minus a, let's generalize. This is a translation of a 0. If I had f of x plus b, where b is just a number, this is a translation, that just means movement, of 0b. Now, in the next final example, why don't we try and do 2 things at the same time? So this time, if we again define our f of x to be x squared, what would happen if we did f of x minus 4 minus 2? Can you think where, if our original x squared graph, let me just put it back to being an x squared, okay, and there it is, right? So there's my x squared graph. What would f of x minus 4 minus 2 look like graphically? So algebraically, this means I need to replace x with an x minus 4, so x minus 4 all squared, and then I've got to take away 2 afterwards. So that's what I'll be typing in. What is that going to look like graphically? Well, let's do it. We're going to have x minus 4, and then we've also got to just write in a minus 2, and there it is. Now, that minimum point has moved 4 to the right and 2 down. So it has done both things simultaneously. So if I have f of x minus a plus b, it is a translation of ab. A spaces to the right and b spaces up. Okay, just happened that in that example, that b was negative, so it went down. Right, hopefully you've understood how that works and you're ready to answer some questions on transformations of functions where it moves as a translation.